Angles are angles that are on the circle. Okay, there are angles that are on the circle, and what happens is they intercept what's called an arc. So they still run into the same arc spot like they would like a central angle, but they just call it an intercepted arc. Very similar to what we've done in the past, in terminology-wise. Okay, so inscribed angle, intercepted arc, and there's of course going to be a relationship between the two. Pretty darn simple. Excuse me. Where you get this. The measure of an inscribed angle equals half the measure of its arc. The inscribed angle equals half the arc. Or double the angle, get the arc. So like I said before, if this theta was 88 degrees, that means that this arc was how much? 88, which means that this angle then is 44. That's all it means. This is a really quick, simplistic-ish style thing that we do today. Okay? Bless you. So, let's see. Measure, inscribe. Angle equals half the measure of the arc. Double the angle equals the arc. Pretty quick. Okay. Just did that. So we've got a couple of quick diagrams and stuff like that just to work ourselves through. There are only maybe 2 other rules that we have, and then we're just gonna have a bunch of pictures to work off of. Excuse me. One of the things that you'll notice is in this diagram, what is CB? It's diameter. Good. It's a diameter. So that means that knowing that you have a diameter, we have one inscribed angle, we have one arc, we can actually figure out everything else that's sitting in there without too much of a hassle. Okay. So as I'm looking at one like that, you have angle ABC is 50, which means what's the arc AC? It's 100. Hold your. That means the arc has to equal how much? I'll get over it. Get 100 here. See how fast that is?
No.
Which means, how much is the arc AB?
24.
How much? Arc AB.
AB would be.
Remember, guys, what's this? So if this is 100, how much is left here? 80. Let's stop overthinking it. If the arc is 48, what's the angle that it hits it? 24. Which means, what do you have left then for CD? 132, very good. Because you know a diameter, you've got one inscribed angle, and then you also you have the other bits. Very, very quick. Okay. Yeah. 24. Angle C is an inscribed angle. It lands on the circle, so it hits an arc. It's equal to half that arc. That's it. All right. Just like this one was, if this one was 50, going the other direction, they double it. If I go this way, I cut it in half. Excuse me. This is actually really easy to think about here. Two inscribed angles of a circle intercept the same arc, they have to be congruent. If you think about it, if you have 2 angles that intercept the exact same arc, in this example on the board I have one at 88 degrees, that means this has to be 44. If I draw another angle that intercepts the exact same arc, what does that have to be?
44.
Has to be, because it always equals half of the arc. No matter where I put it, no matter where I place it. Since it still constantly hits that same exact arc, the angle will always be the same. Because no matter what, the measure of the angle is always half of the measure of the arc that it hits. Doesn't have to be, it can be placed anywhere in here. It can be placed anywhere, okay? I think that's pretty self-explanatory if you start thinking about it. So, like I said before, you get these two angles being the same, C and D, because they hit the same arc. Whenever you have two angles that hit the same arc, why don't you sit them that way? Because then you never have to worry about looking around me. It's a whole new perspective on life now. Look at that. Look, I can stand here and you don't have to try to look around me. All right, so since they hit the same arc, they have to do the same angle. And you can continually draw these things in, no matter what. It will always, always work. Just like I did on the whiteboard. Bless you. Put another one here. Hey, that's going to be the same. Put another one way up there. Hey, that'll be the same. And so on and so on and so on. Since they run into the exact same arc, by rule, oops, we can write that up here. The measure of an inscribed angle equals half the arc. So, like I said, if you're hitting the exact same arc over and over and over and over again, half of the same number will always be dun, 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 the same number. I know, it's crazy to think of. I'm trying to pace yourselves. You guys look very worried. Why? You're just waiting for the bad stuff to happen, right? Oh wait, we just did one like this. We don't need this one. We did one. That's a bad day. Excuse me. Let's see what we can figure out. Yeah, that's a bad 52, sorry. So, notice this arc, this angle hits arc KN. The angle's 52, what's the arc? 104. So if the arc's 104, what's angle M? 52. Pretty much. Probably. What if we did this? What would, if any inscribed angle hits a diameter, what will it measure? If an inscribed angle hits a diameter, what will that angle always measure? 90. Because what's the measure of the arc of diameter? 180. So if I make an angle that intercepts a diameter, what does this always have to be? No matter what, doesn't it? No matter where you put it. Because it's intercepting a diameter. So no matter what, again, by rule, the measure of an angle always equals half the arc. So what they do though is they word it just ever so differently, just slightly. If the inscribed angle hits diameter, it's a right. Very easy. It's just one of the rules that always works because, once again, the measure of that inscribed angle is always equal to half an arc. Diameters always have arcs of 180. That will never ever change. No matter how big or how small the circle is, half a circle is always 180 degrees. Also, half of 180 degrees is always going to equal, dun, 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 how much? Half of 180, which is 90. Always, always, always. Okay? It doesn't necessarily have to be a special right triangle or anything like that. It just winds up being a 90-degree angle on the circle. Which does mean that eventually, yes, you will see some fancy stuff that happens. Okay? So far, so good? Okay, let's give a look at that. The sideways look at that. You all right? Line. Inscribed polygon. We actually have done this a couple of occasions by constructions. Right before spring break, I had you guys draw up an inscribed pentagon. Remember that? Where we had all of our vertices were on the circle. Basically, all this means is that a polygon is inscribed if and only if the vertices lie on a circle. That's it. That's all that means. No matter what shape it is, you can always inscribe it into a polygon, or excuse me, into a circle. It's a very common thing that you will see as we get into chapter 11 and into 12. We do a lot of inscribed work, and that's close enough. You'll see a lot of stuff like this because what we're going to do is we will find areas of shaded region. We'll find the area of just that little chunk right there. Things like that. Just formula work and a little bit of subtraction. Okay. We actually do another part in towards the end of chapter 11 called geometric probability. Again, it's just like using and finding area, but you put an extra step at the end because if I wanted, you guys know what probability is, right? Good chance you're messing with me. You like that? If I have a single-sided, if I have a die, a six-sided die, what's the probability I'm going to roll a 3? 1 out of 6. Okay. So because it's favorable outcome over total outcomes. So the probability of landing in a shaded region would be find the area of the shaded region divided by the total area of the whole object. So we can actually do stuff like that without too much of a hassle. It kind of helps if you ever start, dartboards. Dartboards are all giant geometric probability pieces. That's why certain things are worth more points versus other because it's harder to get to. It's the same idea as you get into all gambling. Is real. Yeah, seriously, it's all. As you get into gambling, the more difficult of a fair.
Gambling's not allowed in school.
I'm not gambling in school. I'm explaining gambling via math. Difference, big difference. Okay. So I know that in Algebra 2 we do a big chunk of probability statistics, and I know that I do a big round on stuff like that. Oh, this is easy. A right triangle is inscribed in a circle. The hypotenuse is always a diameter. It has to be because if the right angle is inscribed on the circle, the right angle is on the circle. What's it always going to run into? Diameter. And what's always the segment opposite a right angle. It's a hypotenuse. In this case, it just happens to be called a diameter because it's inside of a circle. All right. Again, it's not anything that you wouldn't have recognized had I not just written it down. It is one of those pretty self-explanatory style problems as we look through. Okay. Thank you. All right. Just to forewarn you, a diameter consists of what? 2 radii. Good. There has been times that somebody might ask you, oh, what's the radius of this, after you go through and have to do some right triangle stuff. It is a very common thing. Like Whiskey, like you asked me a second ago, what on the circle equations, it asked you for the diameter. Well, in the circle equation, you had junk squared plus junk squared equaled r squared. So if it equals 64, you took the square root of it and doubled it. Okay? It's things like that that will show up. It's not that it's a very difficult thing, but it's going to remind you that, hey, knucklehead, diameter is 2 radii. So who's going to divide it out? Okay? Just a little warning that it does show up. All right. I think this might be the last one that I had. Horribly written bad.
Why'd you type if with 2 F's?
If and only if is what it stands for. Write stuff down there. Come on. Quadrilateral can be inscribed in a circle if and only if opposite angles are supplementary. Okay. Whenever you take quadrilateral, quadrilateral has how many sides? 4. Any 4-sided figure you can fit into a circle. If that happens, those opposite angles will always be supplementary. Always, always. Supplementary means they add up to equal how much?
No, 180.
180. Okay. Excuse me. So my bad diagram here, it would say that angle A plus angle C equals 180. Angle B, angle D is 180. Quadrilaterals have to add up to equal how many total degrees? 360. Okay. Now, we may sometimes in this have to do a little bit of algebra. This is about where the algebra comes into play. Okay. Where you have supplementaries, knowing you're going to have x's and 2x's and stuff like that. I have a handful of examples that we'll go through here in a minute. I printed out a worksheet that has a ton of examples. That way you don't have to consistently draw circles. I just wanted to kind of get through some of the rules at first, and then we'll go from that, okay? But I forgot the hole punch it. We have staplers. Hey, if 2 things equal the same thing, what can you do? I can swap them out. Very good. So do these both equal 180? So that means in the back of your mind, you might be able to do this. Angle A plus angle C. Angle B. You might be able to do something like that if you had to. It's one of our proofs. Yeah, substitution. Putting something in for something else. Yeah, just a little heads up, that does show up in this stuff too. Okay. It's nothing too crazy, it's nothing too difficult. It's just one of those things that does show up. Okay, just gotta give you guys the worst case scenario. Okay. I don't think you need to draw this. What's angle X? 80. What is angle Y?
120.
120. What is arc? DAB. What is arc? DAB.
The measure of the inscribed angle is half of the arc.
Oh.
Once again, let's go back to what angle X was. What is angle X? Okay, maybe we should draw this out. All right, opposite angles are what? Supplementary. So what's angle X? 80. So this is 80, which means it runs into this arc here. Oops. What's that arc? Try again.
That'd be 280.
160, thank you. Remember, the arc, the angle is half the arc. Oh, my
You
brain
guys,
is
if
hurting.
you, just maybe so you don't mess up, if every time you just write the measure of the angle equals half the measure of the arc, and then plug in what we gave you, here we gave you the angle. So 80 is half of what number? Multiply each side by 2, you find the measure of the arc. Just go back to your algebra. It's a little extra work if you can't just do it, but maybe you need that because it's Monday, first hour, I don't know.
This is very frightening. Very
You're
frightening.
scaring Mr. Murphy now.
Yes. Well, that's what I do. Let me give some problems, let's kind of walk through some examples and see how we do. Yeah.
You go to B.
But then if you go on Thursday, it's like Thursday.
This
I know. You're welcome. I had contemplated going on Friday.
then I'll have some
Yeah.
360, right?
It's still a,
He said 86 and 100. So it can't be 160. This has that's 120. He said 160. That's 120.
All right, let's look at a couple of these real quick.
That's what I'm gonna keep it.
Now, you guys know that I am a big fan of giant put together problems. So as you go to the one in the middle, you have one diagram with 8 questions to it. Now, what I want you guys to remember to be able to do is I don't want you ever to worry about answering or reading the questions until you have filled in as much information as you can onto the diagram. That is the easiest way to set stuff up. Now, I believe in the diagram itself, it tells you that you have, it doesn't tell you what is MP or NP? What does it have to be in the picture? It's got to be a diameter. So if it's a diameter, it cuts it into 2 halves, okay? So knowing that, if this is 118, what's the leftover arc here? 118, this would be what, 62? If this is 68, you see, you guys can't assume that it's 68 because 8 plus 8 is not going to equal 0. Use a calculator. What's going to be left over here for 112? All right. Oops. Messed it all up here. Now look again. You knew you had a diameter. What do your 2 angles have to be at Q and angle O? They both have to be 90 because they ran into a diameter. The measure of the inscribed angle, the angle that it runs into, the angle runs into half of an arc. So if the arc is 180, that makes these both 90 degrees. Okay? Then you go on to the next bit. If I follow through here, this arc is 68. The angle that runs into it is here, which means that has to be very good. On the other side, how much does it have to be? 31, good. If I go down here to QPN, see how it runs into the 118? You're going to do a lot of this. See how I just drew out the lines going out through the circle? A lot of times if you extend those lines through the circle, it helps you to visualize what arc it runs into a little bit better. So it's just a little bit easier. So what's half of 118?
59.
59, good. What's half of 112? Now, in looking at that then, I'm pretty sure you have every arc and angle. Read the questions then. That's how you do these things, guys. Never go question by question, because it'll take you too long, and you'd have to backtrack and go do all the other stuff. It is so much just so much easier just to start at the diagram and fill in blanks, okay? Does that make sense by doing it that way? You're gonna start to see a lot more of this stuff, especially with circles, okay? I actually have a couple of questions later on this week. Hopefully we'll be able to get to it Wednesday, I'm guessing, where I have one diagram that has, I don't know, 30 questions to it, 24 questions, something like that, just out of one diagram, okay? Not so bad? All right. Where is it? Okay. The one directly above it, number 9. You have multiple steps to get to it. It is asking you to find the measure of the arc BC. The measure of the arc BC is down here. Well, in order to figure that out, you have to first figure out what angle. I have to find A to get to this arc, but in order to get to A, you have to find C, and what's C? Bless you. It's how much? 90, good. It's angle C has to be 90 degrees because it runs into a diameter. That makes angle A then, well, remember, 64 and something have to be complementary to one another. So it is 26. The angle is always equal to half of the arc that it runs into. So if the angle is half the arc, that means if you double the angle, you get the arc. And you get 52. Good. Now, could you check yourself here? You could, because you have another inscribed angle at 64. If I double 64, you get, what would that be, 128? Do these two add up to equal 180? Then you didn't done. Okay. All right. Flip that over. Let's try the fancier ones. Let's look at 30. I believe it says find the measure of A and C. Well, in order to figure out angles A and angles C, you have to start with what you know. I know that angle B is 31 degrees. If you follow angle B, what arc does it intersect? What is it? Whoa, whoa, whoa. You're telling me that angle B,
Extend those edges.
extend the lines out, what arc does it hit? AD. Not AC, AD. So, if the angle is 31, what's the arc? 62. Which means, what's angle C? 31. Going on the other way. 73 runs into BC, which means BC is going to be double the 73. What do you get? 146. And look what else runs into that angle. You do a lot of this out and back when you have these types of diagrams. They're not difficult. You just have to look carefully at them. Okay?
I know it's not asking, but could we find that third angle in those little triangles?
Absolutely.
Shall
And
we?
we don't. We gotta save some because there's another way to find those angles as well. because they run into two different arcs.
Oh,
You're getting ahead of yourself. That's 10-5.
maybe it's tomorrow.
Anticipation. Let's see it. Yeah, these inscribed ones are so simple. Okay. Questions? I thought it'd be good to show you how not have to worry about drawing all those out as far as examples are concerned. Let me give you some homework. Got a little bit of time today. Yeah, the other side of the school. Yeah, we'll do all of these on here. I will walk you through one of the algebra ones at the bottom on this one here, guys. If you give me a second, pop these things out to you. What's that?
Do we even need this sheet?
No, I just did it so you guys had to draw out along extra examples, that's all.
Here.
You're pulling trees from this.
Well, I figured I would be easier for me to have examples for you guys, not to have to continually draw. That way we can get through more examples. That's the way I was looking at it. So let's see here, that was.
Any extra ones, guys?
If you scroll down to the bottom here, some of these can get kind of messy if you're not careful. I'm going to look at number 20. I'm going to look at number 20 and kind of help you guys set up one of the algebra style problems. Okay. Now, remember, if you have a quadrilateral that's inscribed, that means the opposite angles are always going to be supplementary. That was the one rule that we had about these. So now if I'm looking at that, if I start with looking at angle B, angle B intercepts how many degrees? (164). Okay, everybody see that? So if angle B runs into 164, what is angle B? Whoa, 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 whoa. 82. This whole arc here is 164. Half of it gives me 82. Angle B is 82. Angle B is opposite which angle? D. Therefore, those two are supplementary. So that means that I can do 7y plus 82 is the 180. Okay, that's one way to do it. How many degrees are in a circle? 360. So if you look at it, you have 152 and 164, and you've got this little leftover chunk. So if I take 360, subtract the 152, and subtract the 164, what are you left with? How much? 34. So that means that arc AB, oops, is 34. Are we okay with that? Now follow back to your diagram again. Angle C runs into the arc. Oops, went too far. Angle C runs into the arc here at 84 and 34. What's 84 plus 34? 118. So that means that angle C has to equal half of 118. 59? So then you would write out 4x equals 59.
that's how some of these algebra ones are gonna work. Just wanted to show you that, because we didn't have a good algebra one on the other one, okay? You should be able to knock that out without too much of a hassle. The first group of problems will take you all like 6 minutes. All right?